Good morning. This is Michael Dong on video episode number 23, HPLC Troubleshooting, including strategies, problem diagnosis, and solutions. Here is the agenda on HPLC Troubleshooting. First one is General Diagnostic and Troubleshooting Guide. Second one is a common HPLC problem. We divided problem encounter into 4 category of problems, including pressure, baseline, peak, and data. And we use a illustration of symptoms and mitigation solution, how to minimize these type of problem. Finally, we have a couple of case study, problem with blanks, peak area precision, and assay data accuracy situation. This video is based on the chapter 8 of this book over here. Some general troubleshooting strategy. I like to quote a famous quotation from Benjamin Franklin: "An ounce of prevention is worth a pound of cure." So preventive maintenance is really a very important solution for lessening the troubleshooting situation. Some guidance are verify that a problem exists, right? So if you have a problem once, it's not a problem. Repeat the experiment. If there's the same symptom shows up, then it is indeed could be a problem. Often we are totally lost and we should go back to a documented reference application. And I would actually show an example of using a QC, quality control reference material chromatogram, to illustrate that when that can be applicable. Generally, it's nice to isolate problem area by doing the simple things first, like the visual inspection. For instance, inspect equipment for leaks, loose cable. Often you can use the equipment's built-in diagnostics, such as water's pump. They generally equipped with water's compressional test. And also doing the simple things first, the easy things first, and try to change one component at a time. Finally, there are many resources by manuals, digital resources such as CD-ROM, web resources, and finally, you can call the expert or support line from your vendor or the manufacturer. So it's always good to learn how to do some simple repair yourself, as explained by the previous video, and note when to leave the elaborate ones to service specialists. Here's an example of the quality control reference material, which is marketed by Waters Corporation, shown here with a chromatogram. The kit came with a column, also the sample, which is a sample with 7 pharmaceutical compounds shown here, and a column and a reference standard with some documented parameters. It actually tell you how to make the mobile phase, which is very simple, a 3.3 minute gradient at this flow rate of 0.83 using 2854, and you inject 2 microliter of QC reference standard. So this type of test can be run very rapidly to check out the precision, can check out a lot of the problem from pump and let you diagnose it under grading conditions. So common problem we mentioned are 4 category: a component malfunction from the different major modules, a column situation. Mobile phase could be a situation of the cause of the problem. Sometimes filter, tubing, degasser could be a problem. Next is pressure type of problem, which can come from leaks or something is being plugged up, like the frit or the inlet frit of the column. Next, the third one is chromatogram, typically manifests itself in terms of baseline noise and also peak type of problem. Finally, data performance problems such as sensitivity, retention, inconsistency, precision, problem of peak area, and also often sample recovery situation. So quickly going to pressure problem. So pressure too high, typically a blockage. Those underline the most common cause of that problem, right? So column interference is typically the first thing you suspect. What to do? You can isolate pressure source by disconnecting one component at a time, and most likely is this column. So you can backflash the column, or better yet, replace the column. Pressure too low. In the old day, a piston seal is a major situation, but modern pumps are getting better. Very rarely I see a situation where the piston leaks between the annual preventive maintenance. Occasionally, tubing connection could be a situation. More commonly, in some of the older pumps, the tendency to lose the prime, meaning that uh, the uh, the drivetrain on the piston somehow that it doesn't reset to its uh, position. It just lost itself, and you need to kind of reboot the whole pump to fix that. And also very commonly is bubble trap in the check valve, most likely a mobile phase A check valve. And those are the list of what to do, how to identify the source of leak or malfunction. Next category, baseline problem, show you in terms of picture, noisy baseline, a very common cyclical noise. Synchronous noise are typically caused by the pump, right? We talk about that later. This spike are very easy to diagnose, and we will talk about that later. There are other which are less common, like asynchronous noise. No peak is a big problem, right? It could be due to a multitude of situation. Drift, positive and negative peaks. Uh, okay, so if you have a very noisy baseline, once you turn to the pump and the noise go away, and then definitely it's a pump related. Also, you have a very noisy peak, right? So most likely it is your deuterium source in the UV detector aging of the lamp. So noisy baseline primarily caused by the lamp energy, the deuterium lamp being O. So quick replacement of the lamp would fix that. Could be other situation, but that's less frequent. Synchronous noise almost always caused by the pump, most likely air lock, air bubble trap in the pump head, mostly the inlet pump head. Occasionally, the check valve can be completely plugged, but check valve is one of these things that get replaced by the preventive maintenance program. More so, particularly with UHPLC, more frequent with the binary pump. If you use a mixer which is too small, and you're trying to mix two components which might have some chromophoric property, uh, then you have this type of situation, asynchronous noise, which is synchronous, probably to one of the pump, most likely pump B, and increasing the dwell volume of the mixer volume would generally fix the problem. So quite common for binary UHPLC pump because people like to use a smaller mixer, which is not the best situation. Asynchronous noise can be due to a multitude of things. The issue is very often to diagnose and probably is not a common situation. Baseline drift can be very common related to the gradient, uh, where you have solvent B, which absorb more than solvent A, giving you a rising baseline. Could be other thing like component eluding off the column under isocratic condition. Could be also solvent leak. It's also very problematic with refractive index detector conductivity detector and also electrochemical detector. But in general, UV detector are pretty robust. A cyclical baseline is generally uncommon and often very difficult to diagnose. Uh, in some situation where you have older electrical situations on older laboratory, and also when uh, the HPLC equipment's plugged into a circuit, which let's say being used by a air conditioning window unit compressor, for instance, something like that, or close to a uh, another piece of equipment that's in drawing high electricity. So that could be a situation in here. Other situation, baseline disturbance during the close to void time, which is very common because when you inject a diluent, uh, that usually you get a up and down blip, which let you identify the void time or the void volume. Sloping baseline during gradient elution is also very common, particularly visible under very high magnification and expanded scale in your CDS. Sharp spikes on the baseline are almost caused likely by outgassing of the mobile phase in the detector flow cell. Uh, Often, when you do UHPLC with high flow rate and very high pressure, there's so much build-up temperature because the temperature at the end of the column is generally up to 20 degrees higher. So it can boil the acetonitrile or methanol in your flow cell, right? So it can be eliminated easily by adding a little bit of pressure restrictors, let's say a short piece of tubing up to 50 psi. Some system like the Waters UPLC automatically have a pressure regulator at the end of the flow cell. A peak problem could be manifested in many different ways, and I show you a list of some of the most common cause. We have poor resolution, most likely bed column, broad peak, also column related. So column is the main culprit. Split peak, column inlet problem, or the diluents being too strong. Tailing peak could be absorption or solenophilic activity with the basic analyte. Could be also bed column. Fronting peak are generally related to sample overload. Extra peak could be contamination, could be analyte from a previous injection for isocratic analysis. No peak is indeed a big problem. It can be due to multiple causes. Injector not working properly, no flow from the pump, big leak, detector is not working, column retaining all the compound, you're using the wrong mobile phase, uh, you have injecting the wrong standard, or if you are doing method development, you're injecting the same cocktail or mixture, the sample can be depleted that you did not realize. So here's some chromatogram showing a voided column. Voided column meaning that somehow a column inlet develop a void, and you get this type of really bad chromatography. Sometimes the peak is even split over here. Now, most column I mentioned would not stand high pH mobile phase above 8. So here's a situation where the column is exposed just for a minute to a 0.1% ammonia, and you can see that actually the column get voided. And once you have this type of situation, you just have to throw the column away. Peak spreading is very likely caused by the diluent being too strong, right? Show you in this graph here, if you use weaker diluent, you have good peak shape and good efficiency. If you inject a stronger diluent, depending on what the volume you inject, you can have this type of situation or this type of situation. Or in some cases, you can have some of the main component being eluted off with the solvent front in the worst case scenario. If you try to inject 10 microliter of DMSO, which is a very common solvent or diluent for drug discovery sample. If you try to do that, that usually does not work well under isocratic condition or even gradient condition if you try to inject a large amount such as 10 microliter. Here's a situation of extra unexpected peak. These are isocratic analysis. You can see that sample A looks very normal. Sample B looks the same, except there's an extra peak, which is much broader, and that's because this one came from sample A. Tough to remediate this type of situation, right? You can program a wash after every injection, which is not ideal. There are assays which people would not use isocratic analysis because of problem like this, such as in bioanalytical, they always do things under gradient condition for PK analysis and bioanalytical testing. Okay, here we have a situation when peak broadening are occurring mostly with the early eluted or the early portion of the gradient sample. You can see in a normal chromatogram, it looks like that with column with the band broadening, which you expect under isocratic condition, right? In the lower graph, you can see that the initial peaks are getting broader, right? So it could be due to extra column band broadening, such as the detector flow cell is too big when you use UHPLC column on an HPLC detector with large volume of the flow cell, and also very likely caused by the inlet fitting connection not being done. There's a void in there. So when you make a connection, particularly on the inlet fitting, make sure that the tubing is pressed inside, bottom out at the fittings. This list shows data problem in several category, retention time inconsistency, and show you some of the top causation, the cost of these things. And once you know the diagnosis, you know how to replace, how to fix it. Like proportionation is bad, then you replace that. Insufficient column equilibration, then you make sure that the column equilibrated with sufficient time. Peak area imprecision are mostly caused by the injector or the sampler, or the injection volume being too small. So now, often you can actually make a very small injection, like 0.5 microliter, even on UHPLC, you can do that, or even sometimes 0.1, but don't expect a high level of precision when you make such a small injection, because it's very difficult to do that. Occasionally, particularly with low solubility drug substance or drug products with the API, there could be sample recovery issues from sample preparation, such as insufficient extraction, incomplete extraction, and things like that could give you sample recovery issues. Sensitivity problem could be due to sample absorption, not enough sample being injected. Other things such as the wrong detector wavelength and other situation. I want to show a couple of case study. Okay, ghost peaks are to be expected. Small amount, small number of ghost peaks which emerge from your blank injection. But they should not be too big. It should not be more than should be less than 5 milliabsorbance unit on them. So here is one situation that I have encountered where we see ghost peak even without an injection, and that eventually traced to resistant contaminant is a brand new UHPO system from a newer vendor. And the vendor actually recommend the use of this magic solvent mix, which is methanol, acetonitrile, formic acid, and isopropyl, 4 weight percent each. Just mix them neat, and definitely the column must be disconnected offline, and just wash out the the brand new UHPLC, and after that, uh, the blank gradient ghosting peak is gone. Another example, right? So he is demonstrating the ghost peak situation. Uh, uh, so normal baseline, there might be a small number of ghost peak less than a 5 milliabsorbent units, and you can label them as blank peaks. Occasionally, extra peak most likely came from the contamination in the weakest eluent, which is mobile phase A. Uh, so make sure that the additive on the mobile phase A is highly purified, such as using a good grade of TFA, for example, to eliminate or minimize this ghost peak problem. Another case study, which happened to myself, we are doing some high pH work, and for some unknown reason, a huge ghost peak emerged, which is about 30% of my API peak. After several days of searching, finally we traced the ghost peak to this problem. The ghost peak actually is a contaminant coming from sodium 2-phenylphenolate, which is a preservative commonly used in pH calibration buffer. So when we were titrating the mobile phase A buffer, we dipped the pH electrode in the buffer. And even after extensive racing, for some reason, maybe the liquid junction was kind of not in the best shape. We're not able to rinse it out that particular time. So a little bit of that preservative leach out in mobile phase A and giving you a huge ghost peak. So the fix afterward is that the entire laboratory, we no longer dip that electrode into the mobile phase A. And instead, how we do the titration to get the right buffer pH is to take out a little bit of the buffer after adding acid or base into the buffer, and check it separately into a scintillation vial. And at the end of it, you just wasted that one, and you titrate it until you have the correct pH. Another ghost peak case study coming from one of my colleagues in 2013. And that really slowed her down for about a whole week. And eventually we figure out the problem, right? And the blank should be like this, but for some reason on that week it become like that. We trace it to a situation from the central dishwashing service when they changed their detergent formulation, and for some reason they did not clean out the detergent well, and that actually give you that ghost. So once we diagnose the problem, it's very easy to rinse out the solvent reservoir uh, using acetylnitrile, and then rinse it out again using water, and the ghost peak just went away. But that took several days of soul searching to get to that point. So case study of autosampler imprecision. Okay, this is called the OQ, or operational installation, where we do 10 injection. Now this is on the older system, a very archaic Waters 717 autosampler. And the OQ call for precision less than 0.5% RSD under these conditions. And before we change that external sampling syringe, right? So after we change the external sampling syringe, it is back to 0.3, which passes the OQ. But even 0.3 is not that great, right? Because most modern autosampler have no problem doing it daily at 0.2% RSD. Case study 2 was a data accuracy problem. We are analyzing a clinical sample, phase 0 sample, clinical phase 1 sample, which is using a suspension drug product. The method called for injecting 10 sample, which is from the same clinical suspension. We do 5 sample prep, and each of that sample we would do a duplicate preparation, right? So the percentage label claim is very strange. You can see that, you know, for the some of the sample is close to 100%, other ones are just bad, right? So we have a situation called a suspect OOS or our specification. So once you have that, you have to do a laboratory data analysis, LDA, right? So the manager actually look at the data, examine the system suitability, which is great, which is okay, and finally trace to the problem of incomplete extraction, right? So a procedure called for ultrasonification of the suspension to extract the drug quantitatively. And for reason, some of them were not extracted quantitatively due to the low solubility of the API in methanol. So to fix that, we actually analyzed the retained sample, resonicate them, and everything is within specification. So it's not a OOS situation. It's not the preparation of that clinical trial sample is correct. It is the non-robustness of the sample prep which was a problem. So to fix that, we changed the method for extraction. We make the extraction sonification longer. We do it twice, and in the middle we do a shaking, and after that, that's no problem. So here's a summary of today's video or seminar. Um, just summarize with the most probable cause. Pressure too high is mostly the column. Too low, pumps or leaks from the column inlet. Noisy baseline, O-lamp, mobile phase. A no peak, likely a detector, most likely maybe injector. A bad peak, mostly column or mobile phase situation or diluent. A data problem, retention time degassing, could be the proportionating valve. Peak area, most likely autosampler, lamp, and accuracy, likely autosampler, reference standard prep, or sample preparation. Here's my reference list, and we want to point out that chapter 7, 8 of the book is a good reference source, and also some of the white paper here. So on this last slide, we cover video number 23 on HPLC troubleshooting. We discuss strategy, problem diagnosis, and mitigation solutions. Please subscribe to the channel for previous or future videos. On that note, thanks for your attention and goodbye.